Hello everyone, good morning. How are you? So today we are going to talk about our next topic, that is thermodynamics. Okay, we are going to talk about thermodynamics. So here in this slide, you can see I have shown delta is equal to Q minus W. This is the first law of thermodynamics, second law of spontaneity. And you can see here, I have summarized about the heat energy also, right? Okay, so now today we are going to talk about our topic thermodynamics. So let's start with our session. Okay, so the first of all, when we talk about thermodynamics, there are certain fundamental things about thermodynamics we must consider. So what is work? So work is what? When a gas is present in a cylinder or in a vessel, it expands or contracts against the external pressure, against the pressure present outside of that given gas. Okay, outside of that given vessel. So whatever the work is done when the gas, whether it expands or contracts against the external pressure, is known as the work done by that given gas. So this work done depends upon the path of a given reaction. Okay, and it doesn't depends upon the function, as it depends upon the path followed. So when we need to calculate this work, how we calculate it? By using a formula, W is equal to P external into delta V. What is delta V? Change in the volume for a given gas. Okay, whether the gas has been expanding or whether the gas has been undergoing into compression. Okay, if suppose our reaction is expansion, then the work done will be minus in sign, P external, V2 minus V1. Here V2 is going to be greater than V1. Okay, and that's why volume will be positive, and that's why the work done will be what? Negative. For compression, what is the case? Volume V2 is less than volume V1. And that's why here W is going to be positive. So please remember these two things. What happens in compression and what happens in expansion. If suppose our reaction is reversible isothermal process. What is the meaning of isothermal? That means temperature is constant. So if our reaction is reversible isothermal process, then work done for that reversible process, the equation is minus 2.303 nRT log of V2 by V1. What is V2? It is the final volume. What is V1? It is the initial volume. If suppose we have given pressure of a given gas, okay, then we will rearrange the given thing, that is V2 by V1 by P1 by P2 by using Boyle's law. We have studied, right? Boyle's law yesterday. P1 V1 is equal to P2 V2. So V2 by V1 will be equal to what? P1 by P2. And this is another equation for a reversible isothermal process. If our reaction is not reversible, but it is irreversible isothermal expansion, okay, then what is going to be the work done? Okay, so here the Q value we have calculated first. So Q is nothing but it will be equal to the work done for the given isothermal expansion. Okay, and what will be that? P external is equal to V2 minus V1. Okay, if expansion is in a vacuum at a zero pressure, vacuum means what? It is at a zero pressure, then the value of work done will be zero, because pressure of external will be what? Zero. Okay, and if a change, whatever the reaction is taking place or the process is an adiabatic process, then you know that Q is zero. So whatever will be the internal energy of that given gas or of that given process, that will be its work done. Okay, so how we know this? So from the first law of thermodynamics. So what is the first law of thermodynamics? Delta U is equal to Q plus W. What is Q? Q is a heat. W is what? Work done. Okay, so by using this equation, we have summarized here all the equation for isothermal process, for irreversible isothermal expansion, for expansion as well as compression. We have determined the work done. So if work done is positive, then the system, then if W is positive, then work is done on the system. Okay, that is what, when is W positive? W कब है positive हमारा? W positive यहाँ पे है, मतलब कौन से प्रकार के रिएक्शन हो रहा है, कौन से प्रकार का ये हो रहा है, expansion या compression. The reaction, the process will be what? Compression is going to take place inside that given process. If W is negative, then work done will be done by the system on the surrounding. So that is why, what is that? It is going, gas is going to expand. Okay. If Q is positive, right? Q is positive, then heat is supplied to the system. And when Q is negative, then heat is lost by the system. So these are the sign conventions we need to consider here. If delta U is negative, that is internal energy is negative, then energy transfer from system to surrounding. And if delta U is positive, then energy transfer is taking place from surrounding to system. From surrounding to system. So is that clear to you? This is the first law of thermodynamics. Energy can neither be created nor be destroyed, although it can convert from one form of energy to another form of energy. This is universally the first law of thermodynamics. Okay, remember this. I know you must be knowing this law. Okay, very, very simple. Remember how to calculate W, how to calculate Q, how to calculate delta U. For reversible process, for irreversible process, whether it is expansion, whether it is compression, or whether the reaction is or the process is taking place adiabatically or isothermally. Okay, isothermal means temperature is constant. Adiabatic means heat is constant. Okay, next. So let's solve certain PYQs depending upon this first law of thermodynamics and how to determine the work done for those processes. So correct option for free expansion of an ideal gas for adiabatic process. As we have talked here expansion is taking place, right? So for free expansion of an ideal gas, we have talked that P external will be what? Equal to 0. Okay, P external will be what? 0. And you know the formula, W is equal to minus P external into delta V. So if P external is 0, what will happen to the W? It will be equal to 0. Okay, again we know for adiabatic process, what is that? Q is what? 0. For adiabatic process, Q is 0, that is constant. So according to first law of thermodynamics, which is what? Delta U is equal to Q plus W. Since here Q is 0, W is 0, what will happen to delta U? It will be again 0. Yeah. So answer will be what? A. Very good. So W is 0, Q is 0. And here what is happening? Internal energy is 0. Okay. And you know that internal energy is what? Function of temperature. So since this is 0, change in the temperature is again 0. So that's why option A is the correct answer. That's why option A is the correct answer. Any doubt in this? Okay, let's move on to the next problem. Okay, next. Yeah. Under isothermal conditions, a gas at 300 Kelvin expands from 1 liter to 0.25 liter against a constant external pressure of 2 bar. The work done by the gas is, so we have given 1 bar ka conversion in terms of joule. So here what is happening? Expansion of gas against a constant external pressure. Okay, expansion of gas against a constant external pressure, and we have given the volume through which the gas is undergoing into expansion, as well as we have given the external pressure also. So we know the formula, W is equal to minus of P external into delta V. Put karo values, minus P external into delta V matlab kya? V2 minus V1. What is given here? V2 is what? 0.25 and V1 is what? 0.1. Put this value, put the value of 2 bar. Okay, what will be the answer? Is equal to minus 2 into 0.25. Here 0.25 into 0.1. So when I will do this multiplication, I will get the answer in liter bar, but we want the answer in joule. So a liter bar ko I have multiplied with the 100 joule, because 1 liter bar is equal to 100 joule. So I will get the answer minus 30 joule. That is option B. Yes. Very simple problem. Everything was given. just here the quick and important thing was we need to convert it the answer whatever we are getting for work done in terms of joule. Convert the liter bar into the joule. Okay, right everyone? Okay, so now let's move on to the next problem. Yeah, so here reversible expansion of an ideal gas is given. Okay, under isothermal and adiabatic condition is shown. So one graph is for isothermal expansion and another graph is for adiabatic expansion. So AB graph is for isothermal expansion and AC graph is for adiabatic expansion. So both the terms are what? Expansion. Okay, no compression term is present here. Okay, both the graphs are for expansion of a gas. So which of the following is not correct? So see here we need to consider about which is not correct, and the question is recently asked in the examination. So here for A process and for B process and for C process, pressure, temperature and volumes are given. Pressure, volume and temperature, pressure, volume and temperature, pressure, volume and temperature is given. You can observe this. Okay, so here we have asked that which is not correct. So delta S of isothermal is greater than delta S of adiabatic. TA is equal to TB. W isothermal is greater than W adiabatic and TC is greater than TA. So here isothermal delta S means what? Change in the entropy at isothermal process will be greater than the change in the entropy with respect to adiabatic process. So this statement is correct. Next statement, TA is equal to TB. Where is TA? TA is this one and TB is this one. So isothermal change is there, right? For isothermal change, temperature is going to be constant, and that's why this statement is again true. Next, the W isothermal is greater than W adiabatic. This is again correct. You can see the work curve here. It is highest as compared to the area covered by this work curve is highest as compared to the area covered by this adiabatic curve. So that's why work of isothermal will be always greater than the work for adiabatic. So the last statement you can see here, temperature TC will be greater than temperature TA, initial temperature. Okay, so for an ideal gas, as we know, the internal energy is what? Function of temperature. Right now, just I have told you the internal energy, what? Function of temperature. So here final temperature, that is TC for adiabatic process. Final temperature, that is TC for adiabatic process, should be less than its initial temperature, right? Should be less than its initial temperature. So that is TC should be less than TA. It shouldn't be greater than TA. Okay, so that's why this option, that is option D, is incorrect, and that's what we need to find out. So here option D is what? Correct answer. Okay, option D is what here? Correct answer. Any doubts in this? Okay, next move on to the next problem. Yeah. So here ideal gas expands isothermally from 10 raised to -3 meter cube to 10 raised to -2 meters cube at 300 Kelvin against a constant pressure of. Pressure is given. We need to calculate the work done. Okay. So here we know the formula W is equal to minus PdV. Right? W is equal to minus PdV is equal to minus PdV is what? V2 minus V1. Put all the values. What is the value for V2? 10 raised to -2. What is the value for V1? 10 raised to -3. Put the value. Put the pressure value 10 raised to 5 Newton per meter square. Okay. When you do the calculations now, you will get the answer like this way. 9 into 10 raised to 2 Newton per meter. Sorry, Newton meter. Minus sign, with the minus sign. Okay. So minus sign, this is one, this is another one. Okay. The work done of the gas is whether it will be in joule or kilojoule. That is the Q for this. So Newton meter, 1 joule is equal to what? 1 Newton meter. So 900 joule will be, sorry, 9 into 10 raised to 2 Newton meter will be equal to 900 joule. So that's why our correct answer is what? Option B. Simple calculations. See, and recent examples are asked. Okay, recent exams may the questions has been asked. Simple calculations for pressure and volume. Just calculate the work done. Right? Next, and observe the options also, whether it is in Newton meter or whether it is in joule, whether it is in kilojoule. Right? Very good. So now next problem, a gas is allowed to expand in a well insulated container. Okay, a gas is allowed to expand in a well insulated container against a constant external pressure of 2.5 atm from an initial volume of 2.5 liter to a final volume of 4.5 liter. The change in internal energy of the gas in joules will be. So here, first of all, we need to calculate W. As soon as we need as soon as we get the W minus P external V2 minus V1. Okay, as soon as we get the U value, W value, you can easily calculate U value by using what? First law of thermodynamics, Q plus W. Right here, the container is what? Well insulated. Means what? Heat is neither be entered and neither it is going to be outside. Okay, enter भी नहीं होगा और बाहर भी नहीं जाएगी. मतलब this process is what? Adiabatic process. So whatever W value we are going to get, that is nothing but what? Your internal energy. So just put all this value here. So W is equal to minus P. What is P? 2.5 ATM. What is V2? 4.5 minus 2.5. So let's do the calculation. So P external is equal to delta V. 2.5, 4.5 minus 2.5. We get the work done minus 5 liter ATM. Liter ATM, we need to convert it into joule. So because options में क्या दिया हुआ है? Joules दिया हुआ है. हम लोगों को delta U भी joule में निकालना है. So just multiply it by 101.325. Okay, after multiplying whatever the answer you are getting, that is in terms of joule. So delta U is nothing but Q plus W. Q क्या है? 0 है. Q vessel क्या है? Completely insulated. So whatever the value for W you are getting, that is equal to delta U. So here that is what? Option sorry, B. That is what? Option B. Yeah. Next problem, equal volumes of two monoatomic gas A and B. So here we have given two gases A and B. Okay, and for these two gases, they are mixing at the same temperature and pressure. The ratio for their specific heats, that is Cp and Cv, is given. That is Cp and Cv for the mixture is given. What will be that? Okay, so you know that for monoatomic gas of a same monoatomic gas mixture of a same volume, monoatomic gas for a mixture of the same volume, Cp and Cv are how they are related. So Cp is equal to what? 5 by 2 R, and Cv is equal to what? 3 by 2 R. Okay, so just do this division. 5 by 2 divided by 3 by 2. What will be the answer? Yes, 5 by 2 divided by 3 by 2 R. Cp by Cv download हमको पता करना है ना. Cp by Cv. What is Cp? 5 by 2 R divided by 3 by 2 R. R हो जाएगा cancel. ये जाएगा 5 by 3 R. So what will be the answer here? 5 by 3 करो कितना आएगा? ABCD. Very simple. Yes. It is what? 1.6. Okay, it is what? 1.6. So that's why answer will be what? D answer. Simple problem. Right? Next. Okay. So now let's talk about the next quantity. That is what? Enthalpy, which is very, very important in terms of understanding the reactions. Okay, chemical reaction. So you know that enthalpy is a total heat content of a system at a constant pressure. Okay, at that time, whenever you are going to measure the enthalpy, at that time the pressure is what? Constant. So the sum of internal energy and product of pressure volume work. So this is what our first law of thermodynamics. Okay, it is what? Sum of internal energy and it is what? Pressure volume work. So delta H is nothing but what? Related to the internal energy and the pressure volume work. Okay. Yeah, so this is what the expression H is equal to U plus PV, and in terms of change, it is the equation. So here enthalpy at constant pressure is given by delta U plus delta Ng RT. So sometimes when pressure is not given, and we know from ideal gas PV is equal to what? nRT. Right? PV is equal to nRT. So I can write this as equal to delta Ng and RT. What is delta Ng? Delta Ng are the gaseous moles of product minus gaseous moles of reactant. And delta H is what? Enthalpy change. So if delta H is equal to delta U, at that time delta Ng is 0. If it is greater than 0, delta H is greater than delta U. If it is less than 0, then delta H is less than delta U. So we are going to solve the problems about this formula. But please remember, this is again another formula with the help of which we are going to solve more and more problems from thermodynamics. Okay. Next, for any given reaction, if there are solids and liquids only, then delta H is equal to delta U. Delta U. Okay. Enthalpy also changes when a substance undergoes into any phase transition. Okay, that is from solid to liquid or liquid to gas when such phase transition takes place. delta H is changes. Okay, the difference between the enthalpy of products and enthalpy of reactant is actually known as what? Enthalpy change of reaction. Since enthalpy is what? State function, we can calculate this enthalpy by doing just subtraction of enthalpy of product with the enthalpy of reactant, right? And if a given reaction, if there are more number of products, we can sum their enthalpies. And if there are more number of reactants, we can sum their enthalpies. And by subtracting them, we will get to know the enthalpy change for a given specific reaction. Okay, a measured enthalpy of reaction at 25 degrees Celsius and 1 bar of pressure is known as standard enthalpy change for a reaction, and we denote it by delta H0R by using this notation. Okay. Next, very important in order to determine the enthalpy change for a given reaction. So Hess law, which states that if total enthalpy change during any complete course of reaction, if it is a single step reaction or if it is a multiple step reaction, it is going to be equal. If suppose one reaction is taking place in one step only and other reaction is taking place, same reaction is taking place in what? Multiple steps, then the enthalpy change for same reaction, whether it is occurring in one step or whether it is occurring in more than one step, the enthalpy change for that reaction will be same. वही reaction एक step में हो जाए या फिर वो multiple step ले ले, लेकिन वो reaction के लिए जो भी enthalpy change होगा वो same होगा. ठीक है, समझ में आ रही है बात? So देखो यहाँ पे क्या हुआ, A to B conversion. This is a single step reaction. Again, I can do A to C conversion, then C to D conversion, then D to B conversion. So delta H1, delta H2, and delta H3. So what is happening here is one reaction is what? Single step. Another reaction is what? Requiring the multiple step for their conversion. So what will be the total heat change here, enthalpy change? It will be summation of delta H1, delta H2. So ये जो delta H होगा, that will be same to the delta H1 plus delta H2 plus delta H3 इन तीनों का summation. Okay, so this is what the Hess law. So important of Hess law is we can determine the heat of reaction, heat of formation, and heat of transition by using Hess law. Now let's discuss one problem regarding this Hess law. Okay, you can see here there are three thermochemical reactions were given: carbon plus oxygen CO2, carbon plus half O2 CO, and CO plus half O2 CO2. So based on the above equation, find out which of the relationship given below is correct. So here we need to follow the Hess law. How we are going to determine this? So equation 1 is equal to equation 2 plus equation 3. So here ये जो हमारा equation है, C plus 1 half O2 gives CO, right? And CO plus 1 half O2 gives CO2. That is Z. So X is what? X is nothing but it is equal to Y plus Z. X is nothing but Y plus Z. So just do this, write down this reaction. X क्या है? C plus O gives CO2. C plus O2 gives CO2. Okay, यहाँ पे C plus half O2 gives CO. CO plus half O2 gives CO2. So अगर if we add these two ना, what will happen? This CO and CO are going to cancel out. 1 half O2 will give us 1 mole of O2 and CO2 will be present here. So what is X reaction? It is what? Summation of Y and Z reaction, and that's why the delta H for this reaction will be what? जो भी delta H 0 होगा reaction के लिए वो क्या होगा? Y plus Z होगा. ठीक है, समझ में आ रहा है बात? Okay, next problem. Okay, standard enthalpy of vaporization for a water at 100 degrees Celsius is 40.66 kilojoule per mole. The internal energy of vaporization of water at 100 degrees Celsius is. So यहाँ पे हम लोगों को standard enthalpy of vaporization दी हुई है water के लिए, ठीक है, और हम लोगों को यहाँ पे determine करना है internal energy कितनी होगी. So यहाँ पे आप देख सकते हो मैंने आंसर लिखा हुआ है कि डेल्टा एच ऑफ वेपोराइजेशन कितना दिया है, ये दिया है. टेम्परेचर हम लोगों को दिया था 100 डिग्री सेल्सियस, मैंने उसको कन्वर्ट कर लिया केल्विन में. And we need to find out the internal energy. So by using this formula, delta H is equal to delta E plus delta NGRT. So here instead of delta U, I have written delta. You can write anything. You want to write U, you can write U. You want to write E, you can write E. But what are these? These are internal energies. Okay, ये same ही है, internal energy हम उसको कहते हैं. ठीक है, but we need to calculate delta E. So I have rearranged this equation in terms of this. So delta NGRT. So what is delta Ng? Just I have told you that number of gaseous moles of product minus reactant. ठीक है, प्रोडक्ट में क्या है हमारे इनटू H2O लिक्विड गेटिंग कन्वर्टेड इनटू एंथैल्पी ऑफ वेपराइजेशन ना, लिक्विड का कन्वर्जन किसमें हो रहा है, गैस में हो रहा है। तो यहाँ पे कितने गैस मॉलिक्यूल्स है, सिर्फ प्रोडक्ट में गैस मॉलिक्यूल्स है ना, रिएक्टेंट में तो लिक्विड है, दैट्स व्हाई हाउ मेनी नंबर ऑफ चेंज इन द नंबर ऑफ गैसियस एटम्स आर प्रेजेंट हियर, ओनली वन। So let's put that value, you get delta H minus RT, R का वैल्यू पुट करो 8.314 multiplied by temperature 373, do this subtraction, you will get the answer, that is 37559 joule per mole, and in terms of kilojoule it will be this much. So your answer is what, option A, right? So here we need to do certain calculation very specifically and very carefully, because if you will not able to do the calculation carefully, you will not get a good answer. ओके आपको अच्छे से कैलकुलेशन करना है, मन लगा के, कंसंट्रेशन करके, क्योंकि यहाँ पे एक भी अगर आपका चूक गया, देखो यहाँ पे एक ही गैस मॉलिक्यूल था, ठीक है, तो आपने ये एक लिया, ध्यान में रखना है क्या हम लोगों को करना है प्रॉब्लम सॉल्व करते वक्त, राइट? Next problem, consider the following process. We have given a process, okay, we have given three process actually. For B plus D gives E plus 2C, delta H will be. So here we need to calculate delta H value for this given reaction. B plus D gives E, okay, gives E plus 2C. Okay, so adding all this equation, what we are going to get, 1 2 3, ठीक है, मैं ये तीनों इक्वेशन को क्या करती हूँ, ऐड करती हूँ, 1 2 और 3, इन तीनों को ऐड करते हैं, what we are going to get, C, A giving 2B, 2B giving 2C plus D and E plus A. इस रिएक्शन को मैंने रिवर्स कर लिया, ठीक है, I have reversed this reaction like this way. Okay, hello, hello, you can hear me, right? Okay, so what is happening here, A gives 2B, 3B gives 2C plus D and 2D gives A plus E, right? So here I have just summarized these two reactions, same, but I have reversed this third reaction, okay, 2D gives A plus E. तो यहाँ से A कैंसिल हो जाएगा, ये 3B से 2B निकल गए, तो यहाँ पे हमको मिला 1B, ये 2C था, ठीक है, 2C वैसे के वैसे आ गया, यहाँ पे 1D था, यहाँ पे 2D थे, 2D में से 1D चला गया, 1D हो गया, ठीक है, और यहाँ पे आ गया हमारा E मॉलिक्यूल, ठीक है। तो ये रिएक्शन को मैंने जस्ट अरेंज कर लिया, मुझे जो रिएक्शन जैसी चाहिए थी, उसमें क्या क्या पॉइंट्स चाहिए थे उस तरह से, ओके। एंड इफ आई हैव रिवर्स दिस रिएक्शन ना, I have reversed the delta H value also. Here positive was there, I have written negative here. Okay, so just do this calculation, 300 minus 125 minus 350, right? And you will get the answer, that is 175 kilojoule per mole. So what is the answer, A, B, C, D? So the answer is what? Option B, minus C, minus sign is present here, minus 175 kilojoule per mole, right? It is on minus 175 kilojoule per mole. So this is what your correct answer, right? Next problem, let's move on to the next problem. So bond dissociation energies of X2, Y2 and XY are in this ratio. So हम लोगों को bond dissociation energies दी हुए X2, Y2 और XY के लिए, and we need to calculate what? We need to calculate the bond dissociation energy of X2. ठीक है, so let's solve this problem. यहाँ पे मैंने लिखा हुआ है, देखो, the bond dissociation energy of X2, Y2 and XY are x kilojoule per mole, ठीक है। if 0.5x kilojoule हम लोगों को यहाँ पे क्या दिया था, रेशियो दिया हुआ था ना, तो मैंने क्या कर लिया कि x उसको मैंने कंसिडर कर लिया, so 0.5 kilojoule per mole and x kilojoule per mole respectively, ठीक है, x 0.5x and x, ठीक है। तो यहाँ पे मैंने रिएक्शन लिख लिया, 1/2 x2 plus 1/2 y2 gives xy. So overall delta H value is given to us, formation of xy, that is minus 200 kilojoule per mole. Okay, यहाँ पे हम लोगों को मिल रहा है फिर delta H is nothing but summation of bond dissociation energy of reactant minus summation of bond dissociation energies of product. So just do this calculation, that is what equal to minus of 200, हम लोगों को क्या दिया हुआ है उसके बाद, ओके, डेल्टा एच का वैल्यू इज इक्वल टू व्हाट, हाफ, कितने है रिएक्टेंट में, हम लोगों ने सम किए 1/2 इंटू एक्स प्लस 1/2 इंटू 0.x, राइट, दीज आर इन द रिएक्टेंट साइड, ठीक है ना, ये x2 और y2 क्या है रिएक्टेंट साइड में, और xy क्या है प्रोडक्ट साइड में, सो -1 इंटू x, Okay, minus 1 into x. So by doing this calculation, you can find out the bond dissociation energy for X2. That is what 800 kilojoule. That is what 800 kilojoule. So this is what your correct answer. Okay, this is what your correct answer. That is what option C. Right. Next problem, heat of combustion of carbon to CO2 is given to us. Okay. The heat released upon formation of 35.2 gram of CO2 from carbon and oxygen gas will be. तो यहाँ पे हम लोगों को heat of combustion दिया हुआ है. क्या है heat of combustion दिया हुआ? What is the reaction for CO2? Heat of combustion, when carbon reacts with oxygen, we get CO2. And delta H value for that is minus 393.5. So this reaction is what? Exothermic reaction. So amount of heat released due to the formation of 44 gram of CO2 is this much, 393.5. Now we need to determine what is the heat released upon formation of 35.2 gram of CO. Okay, so हमको ये मोल concept पे हम लोगों ने पढ़ा है. See, 35 gram of CO2, 44 gram को required है इतना किलोजूल. So 35.2 के लिए कितना required होगा? Just do this cross multiplication and you will get your answer. That is minus 315 kilojoule. Minus 315 kilojoule. Okay, so here the answer will be what? Option D. Okay, here answer will be what? Option D. Very good. Next problem. When 5 liter of gas mixture of methane and propane is directly combusted at 0 degrees Celsius. Okay, if it is directly combusted at 0 degrees Celsius, what will be your answer? Okay, so can you tell me what will be the answer? Yes. When 5 liter of gas mixture of methane, यहाँ पे methane लेना है हम लोगों को CH4 and लेना है हम लोगों को propane. Okay, methane and propane लीजिए. परफेक्टली उनको आप कंबशन करना है 0 डिग्री सेल्सियस पे, 1 एटमोस्फियर, 16 लीटर ऑफ ऑक्सीजन एट द सेम टेम्परेचर एंड प्रेशर इज कंज्यूम. द अमाउंट ऑफ हीट रिलीज फ्रॉम दिस कंबशन इन किलोजूल विल बी. यहाँ पे दिया हुआ है. ठीक है, सो देखो यहाँ पे मैंने कैलकुलेशन किया हुआ है. मीथेन का मैंने कंबशन किया. ठीक है, मीथेन का कंबशन करने के बाद हम लोगों को क्या मिलता है? CO2 एंड H2. अगेन फॉर प्रोपेन यू आर गोइंग टू गेट द सेम टाइप ऑफ compounds, okay, products, but the number of moles are different. Okay, so the number of moles in a gaseous mixture here, how much? CH4 plus यहाँ पे CH4 plus C3H8. Okay, CO4 CH4, that is methane, plus propane is going to give us 5 by 22.4. Okay, 5 by 22.4, that is 0.22 मोल्स. तो यहाँ पे 0.22 मोल्स कहाँ से आए? 5 लीटर दिया हुआ है ना हम लोगों को प्रॉब्लम में. ठीक है, 5 लीटर. सो वट एवर द वॉल्यूम इज गिवन, डिवाइडिंग इट बाय द 22.4, वी आर गोइंग टू गेट द नंबर ऑफ मोल्स. सो दोनों मिक्सचर किसका था? 5 लीटर का था. उसको मैंने 22.4 से डिवाइड कर लिया. सो हाउ मेनी मोल्स ऑफ द मिक्सचर वाज प्रेजेंट इनिशियली? 0.22 मोल्स. ठीक है, उसमें से हम लोगों को ऑक्सीजन कितना यूज हुआ? उन्होंने कहा कि 16 लीटर ऑफ ऑक्सीजन. So 16 divided by this, you are going to get the number of moles of oxygen. Okay, so let X moles of methane is there in the gaseous mixture. So number of moles of propane will be what? 0.22 into 22 minus X. Then moles of O2 consumed will be, so 2X plus 0.22 minus X into 5 is equal to this much. So what will be the value for X? X का value आ जाएगा 0.13. So this is 0.13 for methane. So how much amount of heat has been liberated? So जो भी हमको number of moles मिले हैं वो उसको हम लोगों ने उसकी डेल्टा H वैल्यू से मल्टीप्लाई कर लिया. प्लस अगर ये इतने हैं X, तो प्रोपेन कितना होगा? 0.22 minus 0.13. Whatever the answer you are getting, that is 0.09. Multiply it by the kilojoule value of delta H for propane. Do this calculation now and you will get the answer in terms of this 315.5 kilojoule. Okay, and what is the nearest value here present? That is what? 317. Okay, option B. So this problem was very means you need to calculate the number of moles first, then assume that the number of moles for CH4 are X, and for another quantity, that is propane, is what? 0. Total number of moles minus of X, and then apply this equation to this given mixture and you will good to know the answer. Okay, थोड़ा ये आपको ज्यादा कैलकुलेशन करना पड़ा है इस प्रॉब्लम में। नेक्स्ट प्रॉब्लम, नेक्स्ट प्रॉब्लम के पहले हम लोग थोड़ी थ्योरी देख लेते हैं। सो व्हाट इज स्पेसिफिक हीट कैपेसिटी? सो इफ सिस्टम कंसिस्ट ऑफ अ सिंगल सब्सटेंस और सॉल्यूशन whose weight is 1 gram, then the heat capacity of that given system, if our system is only 1 gram, then whatever the heat capacity of that given system is there, that is known as a specific heat. So what is specific heat? It is equal to C into M into delta T. What is C? That is what the specific heat. And what is Q? It is what? Heat. What is M? Mass of the substance. And what is delta T? It is change in the temperature. So if the system consists of a single substance or a solution whose weight is 1 mole, okay, whose weight is 1 mole, then the heat capacity of that system is known as molar heat capacity. Then it is known as molar heat capacity, right? So there are two types of molar heat capacity, at constant pressure and at constant volume. So at constant pressure, we denote it by Cp, Cp into M, and at constant volume, we denote it as Cv, Cv into M. What is M? M is a molecular weight. So what is the relation between this Cp and Cv? So Cp minus Cv is equal to R. This is very important. Okay, Cp minus Cv is equal to R by M when this is a 1 mole of gas, and when M is what? A molecular weight given for a given substance. Okay, molar gas. ठीक है, मोलर हीट कैपेसिटी एट कांस्टेंट वॉल्यूम इज 3/2R. मैंने अभी आपको बताया सीवी क्या होता है 3/2R और सीवी क्या होता है 5/2R, और इनका रिलेशन कितना होता है 1.67. अभी हम लोगों ने एक प्रॉब्लम सॉल्व किया था, ठीक है ना. सो 66 किसके लिए होता है? मोनोएटॉमिक गैस के लिए होता है. 40 किसके लिए होता है? डायटोमिक गैस के लिए होता है. 1.33 किसके लिए होते हैं? गामा की वैल्यू. ये पॉइजन रेशियो किसके लिए होता है? Cp/Cv वैल्यू ट्राइटोमिक गैस. सो दिस इज मोनोएटॉमिक गैस, दिस इज डायटोमिक गैस एंड दिस इज ट्राइटोमिक गैस. दिस इज वेरी इंपॉर्टेंट क्योंकि ये आ सकता है, प्रॉब्लम में पूछा जा सकता है एग्जाम में. ओके, सो सी the problem. Equal volume of two monoatomic gases A and B at same temperature and pressure are mixed. The ratio of their specific heat, that is Cp/Cv, for a mixture will be. तो अभी हम लोगों ने ये प्रॉब्लम सॉल्व किया था, फिर से वही रिपीट आ गया है. ठीक है, क्या हुआ है? Cv is equal to 3/2R, राइट. सो मैंने ये कैलकुलेशन किया, आप लोगों को समझ में आया है. क्या आंसर आ जाएगा? 1.66. ठीक है, क्यों ऐसे आया है? क्योंकि हम लोगों ने अभी देखा Cp/Cp मोनोएटॉमिक गैस के लिए इतना होता है, डायटोमिक गैस के लिए इतना होता है, और ट्राइटोमिक गैस के लिए इतना होता है. ठीक है, कौन से गैस मोनोएटॉमिक, कौन से गैस ट्राइटोमिक, कौन से गैस डायटोमिक, प्लीज रिमेंबर दिस. ओके, वेरी इंपॉर्टेंट. नेक्स्ट, एंट्रोपी. सो व्हाट इज द एंट्रोपी? सो एंट्रोपी change for ideal gas. Entropy means what? Randomness present in a given system. That is what, when a component or when a substance changes from solid to liquid, its entropy increases. When it changes from liquid to gas, its entropy again changes. So the randomness increases, the entropy increases. So when we relate this entropy change for an ideal gas for a given isothermal process, isobaric process, and isochoric process, then we can calculate this entropy by using these equations. And you need to remember these equations. Okay, if in the reaction we have given the final volume, initial volume, we have given the pressure, we have given the temperature, then we can easily find out the entropy change for that given change of a system or a process. Okay, so what does second law states us? So second law suggests us that entropy of the system and the surrounding remains constant in a reversible equilibrium process, while it increases in an irreversible process. So that is very important law of thermodynamics. That is second law of thermodynamics, in which total entropy of the system remains constant. Okay, whether it is what? Reversible process or reversible process. In nature, all the processes are reversible, right? All processes are irreversible, that is spontaneous, and they are going to be undergoing into completion. Hence, entropy of all the universe increases and it tends to be maximum. ये सिस्टम और सराउंडिंग की जो एंट्रोपी है ये हमेशा कांस्टेंट होती है, लेकिन जो हमारी एंट्रोपी, टोटल एंट्रोपी है यूनिवर्स की, इट इज ऑलवेज इंक्रीजिंग एंड इट इज always want to be have a maximum value. Okay, next, what is gives free energy change for a spontaneous processes? So you know delta G is equal to what? Delta H minus T delta S. So that is what? Free energy change for a given species. Okay, so ये इस इक्वेशन को हम क्या करते कहते हैं, गिव्स हेल्महोल्ट्ज इक्वेशन. डेल्टा जी इज इक्वल टू डेल्टा एच माइनस टी डेल्टा एस इज नोन एज अ gives Helmholtz equation, and which is very useful. What is delta G here? Gives free energy. It is the measurement of useful work during a process. How much useful work has been done? Okay, that is what the gives free energy. So you know that if it is greater than 0, that is if it is positive, the process is non-spontaneous. If it is less than 0, that is its value is negative, it is a spontaneous process. And if it is 0, then at that time the equilibrium exists in the given reaction. Okay, so the value of delta G depends upon delta H as well as delta S value. So if delta TS is greater than delta H, then only delta G will be 0, and then only the reaction will be spontaneous. Right? If a standard free energy change and equilibrium constant are related, this is a standard free energy change. Okay, this is a free energy change for a given reaction in which all the reactants and all the products are in their standard state. Okay, that's why this is known as a Gibbs free energy change at a standard rate. Okay, standard free energy change. Okay, so it is equal to 2.303 RT log Q. Log Q is what? Reaction quotient. We have seen also this. Equilibrium kya hota hai? Delta G becomes 0. So this will be equal to what? This. And what is K? K is nothing but our equilibrium constant, which becomes equal to the reaction quotient at only and only when the process is at equilibrium. Okay? Next, third law of thermodynamics. So what is third law of thermodynamics? So according to the third law of thermodynamics, the entropy of a perfectly crystalline substance approaches to 0 as the absolute zero of the temperature is approached. Okay, as the absolute zero temperature is approached. So at absolute zero temperature, entropy of a perfectly crystalline substance is 0. That was the observation done, and that was the third law of thermodynamics. Okay, now let's solve the problems depending upon the second law and third law. So what is the answer for this given reaction, for this given problem? Here reaction is given and we need to consider the correct option for this reaction. Okay, so in order to occur this reaction, what should be the answer? A, B, C, D. Yes, delta H is given, that is change in the enthalpy, and delta S is given, that is change in the entropy. Yeah, so here in this reaction Cl gives Cl2. So यहाँ पे क्या हो रहा है? Gas molecules, the randomness decreases. Why? Initially in the reactant side 2 moles were present, but in the final stage what has happened? The 2 moles were getting converted into 1 mole. And what is happening? So here delta S value is decreasing. Entropy का value decrease हो रहा है. So entropy का value decrease हो रहा है, and this is an exothermic reaction, and therefore delta H is again 0, means less than 0. So यहाँ पे क्या होगा? Option D will be correct. Delta S भी less than 0 होगा और delta H भी less than 0 होगा, क्योंकि ये process में क्या हो रहा है? This reaction is exothermic reaction. Okay. Next reaction, sorry, next problem, in which case entropy is negative. Yeah, यहाँ पे हम लोगों को 4 रिएक्शन दिए हुए. हाइड्रोजन का कन्वर्जन H2 में हो रहा है, इवापोरेशन ऑफ वाटर हो रहा है, एक्सपांशन ऑफ गैस हो रहा है, सब्लिमेशन ऑफ सॉलिड टू गैस हो रहा है. तो आप देख सकते हैं फर्स्ट रिएक्शन में फर्स्ट ऑफ ऑल 2 मॉलिक्यूल्स थे, उसका कन्वर्जन 1 मॉलिक्यूल में हुआ है. एंट्रोपी क्या होता है? 2 मोल से 1 मोल में कन्वर्जन हो रहा है, मतलब मॉलिक्यूल्स कम हो गए, मतलब एंट्रोपी क्या हो गई वहां पे? निगेटिव. So that's why answer A is the correct answer. As number of gaseous molecule becomes less, entropy also decreases, or it becomes negative. So next problem, for a given reaction, delta H is given and delta S is given. The reaction is spontaneous at, assume that delta H and delta S do not vary with temperature. So यहाँ पे हम लोगों को क्या calculate करना है? यहाँ पे हम लोगों को calculate करना है कि which relation is true for these values of delta H and delta S. So see here. For a spontaneous reaction, what should be the case? Delta G should be negative, right? For a spontaneous case, delta G should be negative. And for that, delta S minus T delta S should be less than 0. If this should be less than 0, then what we can say? That delta T, see, T should be greater than delta H by delta S. Okay, so T should be greater than delta H by delta. Q मैंने ऐसे लिखा, देखो, delta G is equal to delta H minus T delta S, right? So यहाँ पे मैंने क्या कहा? रिएक्शन क्या है? स्पॉन्टेनियस है, ठीक है? तो ये क्या हो जाएगा? डेल्टा G will be less than 0, ठीक है? डेल्टा G will be less than 0. So मैं यहाँ पे क्या कर सकती हूँ? इसको राइट कर सकती हूँ डेल्टा H minus T delta S less than 0. ओके, ये वैल्यू क्या होना चाहिए, लेस देन 0 होना चाहिए, जो डेल्टा जी का वैल्यू है, ठीक है ना। सो यहाँ पे मैंने क्या किया, ये टी को ये माइनस टी डेल्टा एस को इधर ट्रांसफर कर दिया, सो डेल्टा एच इज लेस देन इक्वल टू टी डेल्टा एस। ओके, अब मुझे क्या है, मेरे पास डेल्टा एच का वैल्यू, डेल्टा एस का वैल्यू, सो मैंने इस इक्वेशन को रीअरेंज कर दिया। दैट मीन्स व्हाट, टी शुड बी ग्रेटर देन डेल्टा एच बाय डेल्टा एस। ओके, डेल्टा एच का वैल्यू दिया है प्रॉब्लम में 35.5, डेल्टा एस का वैल्यू दिया है प्रॉब्लम में 83.6। ओके, सो जस्ट पुट दैट वैल्यू, किलो जूल को कन्वर्ट करो जूल में, क्योंकि डेल्टा एस का वैल्यू क्या है, जूल में, ठीक है। यू विल गेट आंसर 425। सो व्हाट इज द करेक्ट थिंग, सो टेम्परेचर शुड बी ग्रेटर देन 425 केल्विन, right? Any doubts in this? We have just rearranged the equation. Delta G is less than 0 for a spontaneous process. Delta G का वैल्यू क्या है, डेल्टा H minus T delta S less than 0. Rearrange equation and put the value of delta H and delta S, you will get the answer, right? Any doubts in this? Okay, A answer is correct answer. Next, for a sample of perfect gas, when its pressure is changed isothermally from initial pressure to final pressure, the entropy change is given by. So there are 4 equations given here, right? So here what will be the correct answer? Okay, तो यहाँ पे PF by PI दिया है, PI by PF दिया है, PI by PF दिया है, PF by PA दिया है, NR ln, NRT ln, NR ln, NRT ln. Okay, तो मैंने आपको बताया था आइसोथर्मल चेंज है. Okay, for isothermal change, if ideal gas is undergoing into reversible expansion, temperature will be changed from Ti to Tf and pressure will change from Pi to Pa. So this will be the reaction for, this will be the entropy change for a given reaction. But here the reaction is isothermal, means what, Ti and Tf will be equal to same. So that's why this ln will become 0. So what is remaining? Delta S is equal to Nr ln Pi upon Pa. Nr ln Pi upon Pf. So what is this answer? Option B. सिंपल. देखो एंट्रोपी चेंज के मैंने आप लोगों को 4 इक्वेशन लिख के दिए थे ना, तो उनमें से एक यहाँ पे पूछा गया है. Next, the correct thermodynamic conditions for the spontaneous reaction at all temperature is. So we need thermodynamic condition for a spontaneous process. For spontaneous process, you know, delta G should be equal to what? 0, or it should be greater than 0. Yes, tell me. When 0, what is the process? The process undergoes into equilibrium. When delta G is 0, the process is in equilibrium. What we want here, we want delta G should be less than 0, then and only the reaction will be spontaneous. So in order to have the spontaneity, we have just talked here right now that delta H should be less than 0 and delta S should be greater than 0. Then only this gives Helmholtz equation will hold true for delta G is equal to negative and the reaction will be spontaneous. So what will be the correct option here? A and C are the correct option here. Okay, if delta H is negative, T is positive, sorry, delta S is positive, then our delta G will be negative. Again, if delta H is negative and delta S is 0, that time also delta G will be negative at all temperature, and that's why here option A and C are correct. Please remember, दो option यहाँ पे correct है. ठीक है? Yes. Next problem, consider the following liquid vapor equilibrium. So we have given the equilibrium here, and we need to consider this equilibrium and tell me which of the following relation is correct. So when we study the equilibrium between liquid and vapor, that time we get to know about a equation which is known as a Clausius-Clapeyron equation. So among these A, B, C, D, which is the Clausius-Clapeyron equation? So this is Clausius-Clapeyron equation. dln P by dt is equal to delta HV, that is heat of vaporization, divided by RT square. So this is Clausius-Clapeyron equation, and please remember this equation. ठीक है, ये equation के बारे में बहुत बार क्वेश्चन आए हैं. वो okay, below which is the Clausius-Clapeyron equation. ठीक है, इसे भी क्वेश्चन आ सकता है. So which of the following equation correctly describes the liquid to vapor equilibrium? This equation, because this is a Clausius-Clapeyron equation and this is a true. Okay. Next, which of the following statement is correct for the spontaneous adsorption of gas? So here, you know, in surface chemistry also we have talked about this adsorption of gas. At that time, what is delta S value, what is delta H value, and what is delta G value, right? हम लोगों ने उस टाइम पे भी बात किया था. ठीक है, so the gives Helmholtz equation, that is delta H minus T delta S is like this way. So during adsorption, what happens? First of all, gas होता है, गैस में रैंडमनेस ज्यादा होता है, right? It gets stuck on a surface which is a fixed surface. So first of all, gas was randomly moving everywhere, but when it's stuck on a given surface, now what happens? Its randomness becomes less. So that's why its entropy decreases, right? So during adsorption only the entropy of a given gas decreases. So for a given spontaneous process of adsorption, delta G should be negative. So if delta G should be negative, then delta S is less than 0. That is, it is what? Negative. So negative will become positive. So we need delta G should be negative. So for that delta H should be highly negative. हम लोगों को क्या चाहिए? डेल्टा G नेगेटिव चाहिए ना. अगर डेल्टा S नेगेटिव हो गया तो ये नेगेटिव हो जाएगा पॉजिटिव. तो ये डेल्टा H का वैल्यू क्या होना चाहिए हमारे पास? इट शुड बी हाईली नेगेटिव होना चाहिए. So what is the correct answer here? ABCD. So delta B is negative and therefore delta H should be highly negative. Then only we will get delta G as a negative quantity, right? Okay, next, let's move on to the next problem. For a reaction, here reaction is given. We have given delta U, we have given delta S. We need to calculate delta G. So just use karo hamara equation. Delta H is equal to delta U plus delta NG/RT. राइट, डेल्टा यू इज इक्वल टू डेल्टा NG/RT. क्योंकि हम लोगों को यहाँ पे डेल्टा यू दिया हुआ है, डेल्टा एच दिया था क्या? नहीं. डेल्टा जी कैलकुलेट करने के लिए वी नीड डेल्टा एच माइनस ये डेल्टा एस, राइट. डेल्टा एच दिया हुआ है, टेम्परेचर दिया हुआ है, लेकिन डेल्टा एच दिया नहीं था, इसलिए पहले हमको डेल्टा एच कैलकुलेट करना पड़ेगा डेल्टा यू के वैल्यू से. डेल्टा एनजी कैसे कैलकुलेट करोगे? नंबर ऑफ मोल्स इनटू द नंबर ऑफ गैसेस मोल्स इनटू द प्रोडक्ट माइनस नंबर ऑफ गैसेस मोल्स इनटू द रिएक्टेंट. यहाँ पे है 0, यहाँ पे है 2, दैट्स व्हाई डेल्टा एनजी मिल गया हम लोगों को 2. सो बाय कैलकुलेटिंग दैट, यू 2.1 है, ठीक है, एनजी कितना है? 2 है, आर की वैल्यू इतनी है, पुट करो ये सब वैल्यू हमारे फॉर्मूला में, हम लोगों को मिल जाएगा डेल्टा एच 3.3 किलो कैलोरी. पुट दैट वैल्यू इन दिस इक्वेशन डेल्टा जी का, ठीक है, आप लोगों को मिल जाएगा आंसर किलो कैलोरी में ये, ठीक है. 3.3 किलो कैलोरी. डेल्टा एस हम लोगों को कैलोरी में दिया था, मैंने उसको भी किलो कैलोरी में कन्वर्ट कर लिया. I have put all this value in this equation, gives Helmholtz equation, and I got the answer, that is option B, 2.7 kilocalorie per mole. 2. Okay, समझ में आ रहा है सबको? Next problem. A reaction having equal energies of activation for forward and reverse reaction is. So इनमें से कौन सी रिएक्शन है having equal energy of activation for forward as well as reverse reaction? So यहाँ पे जब ऐसा होता है, for any given reaction, they will have equal energy of activation for forward as well as reverse reaction. In which case, so when delta H will be 0 now, at that time they will have the equal energies of activation. Okay, they will have the equal energies of activation. See here, I have shown when delta H is 0, that is activation for forward minus activation for backward. ये क्या है? इक्वल होने के कारण इनके जो वैल्यू हो गई, डेल्टा एच की वैल्यू 0 हो गई. ठीक है, ठीक है क्या? राइट, वेरी सिंपल प्रॉब्लम. नेक्स्ट, इन विच ऑफ द फॉलोइंग रिएक्शन स्टैंडर्ड रिएक्शन एंट्रोपी इज पॉजिटिव एंड स्टैंडर्ड गिव्स फ्री एनर्जी डिक्रीजेस शार्पली विथ इंक्रीजिंग टेम्परेचर. तो यहाँ पे हम लोगों को एंट्रोपी पॉजिटिव चाहिए और हमारा जो गिव्स फ्री एनर्जी चेंज है वो क्या चाहिए? हम लोगों को डिक्रीज होना चाहिए. ठीक है, सो ऑब्जर्व ऑल द 4 रिएक्शंस 1 2 3 4. यू कैन सी हियर ग्राफाइट and here is what? one half O2. This is what? 1/2 O2 gas. ठीक है, वो क्या दे रहा है हमको? CO गैस दे रहा है. यहाँ पे क्या है? 1/2 O2 गैस, वो क्या दे रहा है हमको? CO2 दे रहा है. यहाँ पे भी 1/2 O2 गैस, ठीक है, वो क्या दे रहा है हमको? MgO, वो मैग्नीशियम के साथ रिएक्ट होती है. यहाँ पे भी O2 गैस हम लोगों को दे रहा है 1/2 CO2. ठीक है, आर यू गेटिंग दिस? दिस इज व्हाट द अवर रिएक्शंस, 4 रिएक्शन. इनमें से किसमें हम लोगों को एंट्रोपी पॉजिटिव और गिव्स फ्री एनर्जी निगेटिव दिख रहा है? देखते हैं. ठीक है, तो देखो इस रिएक्शन में जो ए रिएक्शन है, यहाँ पे क्या हो रहा है? हम लोगों को एंट्रोपी क्या चाहिए? पॉजिटिव है. एंट्रोपी पॉजिटिव चाहिए मतलब द चेंज इन द नंबर ऑफ मोल्स ऑफ गैसियस सब्सटेंस शुड बी इंक्रीजिंग, okay, into the product side. So delta S if positive, then only from the Gibbs Helmholtz equation we can say that delta G will be negative. Okay, delta G should be negative. So for the first reaction, यहाँ पे आप देख सकते हो, यहाँ पे प्रोडक्ट में कितने हैं गैसियस मॉलिक्यूल? 1 है, और रिएक्टेंट साइड में कितने गैशियस मॉलिक्यूल, हाफ है। सो कितने हमारे पास बचे गैशियस मॉलिक्यूल, हाफ बचे। ठीक है, समझ में आ रहा है सबको? तो ये जो रिएक्शन है फर्स्ट रिएक्शन, इसमें ही क्या हो रहा है, अमाउंट ऑफ सब्सटेंसेस इंक्रीजिंग into the product side and delta S is positive for this reaction. And from the Gibbs Helmholtz equation, we know that if delta S is positive, thus increasing the temperature. ठीक है, टेम्परेचर अगर हम लोगों ने इंक्रीज किया, हम लोगों को प्रॉब्लम में ही दिया था, अगर शार्पली हम लोगों ने टेम्परेचर इंक्रीज किया, इट विल मेक द टर्म माइनस टी डेल्टा एस मोर निगेटिव। इसको हम लोग मोर निगेटिव करेंगे क्योंकि डेल्टा एस पॉजिटिव है, तो अगर टेम्परेचर इंक्रीज किया उसके आगे तो माइनस साइन है, तो ये टर्म क्या हो जाएगी, और निगेटिव हो जाएगी, और ये टर्म अगर ज्यादा निगेटिव हो गई तो हमारा डेल्टा जी भी क्या हो जाएगा, निगेटिव, एंड दैट्स व्हाई डेल्टा जी वैल्यू विल गोइंग टू डिक्रीज, राइट? Yeah. Next problem, enthalpy of fusion of water is this much kilocalorie per mole. What will be the molar enthalpy change for melting of ice at 0 degree Celsius? तो यहाँ पे हम लोगों को melting of ice निकालना है. You know the formula delta H fusion. We need to calculate delta H. You know that formula delta H of fusion divided by temperature at fusion is nothing but delta S of fusion. Please remember this formula. Okay, delta S of fusion is equal to delta H of fusion divided by temperature at a fusion point. Okay, delta H of fusion दिया है हम लोगों को, enthalpy of fusion 1.435 into 10 raised to 3 कैलोरी में कन्वर्ट करो उसको। क्यों कैलोरी में कन्वर्ट करना है, क्योंकि प्रोडक्ट में हम लोगों को कैलोरी दिया हुआ है इसीलिए। टेम्परेचर दिया है 0 डिग्री सेल्सियस, कन्वर्टेड इनटू केल्विन, यू विल गेट योर आंसर, जस्ट पुट ऑल दिस वैल्यू, will get your answer 5.26 calories per mole. That is your answer is C, right? Your answer is what? C answer. In doubt in this, please remember this equation. This is again very important equation. Okay, fusion वाला equation जो है ये बहुत important equation है. इस पे आप लोगों को कभी कभी delta H of fusion नहीं दिया हुआ होगा, and we need to calculate delta H of fusion, and you have given delta S of fusion as well as temperature. Sometimes temperature has been asked. So ये problem पे, इस formula पे problems can be of different type. 3 types of problem can be asked. एक बार delta H of fusion निकालने को बोलेंगे, एक बार delta S of fusion निकालने को बोलेंगे, एक बार temperature निकालने को बोलेंगे. So this equation is very important. Remember this. Okay, relation between entropy, enthalpy and temperature. Right? Any doubt in this? Yes. Do you have any doubt in this? Just do the calculations, right? किलो कैलोरी दिया हुआ था, कन्वर्ट किया मैंने कैलोरी पर मोल पर केल्विन में. ठीक है, ओके, राइट. डिग्री सेल्सियस को भी केल्विन में कन्वर्ट करना है, हमेशा याद रखनी है ये बात. ओके, या, सो दैट्स इट फॉर टुडेज लेक्चर. इफ यू हैव एनी डाउट्स यू कैन आस्क मी. या, yes, any doubts? Okay, let's meet for tomorrow's